and welcome viewers. Today we are going to learn the primary segment of DAC. A digital to analog converter, which is D2A converter or DAC, is a converter that converts digital signals to analog signals. The DAC has digital input and analog output. They are used in television and mobile phones where the digital video data is converted to analog video signals. Here, the output of a system may be required in the analog form, thus converting the digital output to analog form. The input of a DAC is an n-bit binary signal in a parallel form. Digital signals are available at the output of the registers and latches, and the voltage corresponding to logic 0 and logic 1 is used to drive the converter. These voltages are thus used to operate digitally controlled switches. The switches are connected to one of the two positions depending upon the digital signal 1 or 0, connecting precisely V1 or V0 to the converter input corresponding to 1 or 0. The analog output voltage V0 of an n-bit straight binary DAC is given by V0 is equal to K 2 to the power n minus 1 B n minus 1 plus 2 to the power n minus 2 B n minus 2 plus 2 to the power n minus 3 B n minus 3 and so on till we get 2 to the power 2 B2 plus 2 to the power 1 B1 plus 2 to the power 0 B0. This is equation 1, where K is the proportionality factor, Bn is equal to 1 if the nth bit of the digital input is 1, 0 if the nth bit of the digital input is 0. There are two types of commonly used DACs, weighted resistor DAC and R2R ladder DAC. In this lecture, we will focus mainly on weighted resistor DAC. Let us consider an n-bit straight binary input to a resistor network which produces current I by 2 to the power 0, which is equal to I for logic 1 at the MSB, I by 2 to the power 1, which is I by 2 for logic 1 at the corresponding lower bit, I by 2 to the power 2 for logic 1 at the corresponding lower bit, and so on until it reaches I by 2 to the power n minus 1 for logic 1 at the LSB. Now, the total current produced will be converted to voltage using op-amp, which will be proportional to digital unit. The figure of a weighted resistor DAC is given by, since the resistance values are weighted according to the binary weights, hence the name is given as weighted resistor DAC. A switch is connected to position 1 or 0 for digital input for the corresponding bit being 1 or 0. The voltage applied across resistors is V1 if the switch connected is in position 1 or V0 if the switch is connected in position 0. Hence, the current II is given by II is equal to I n minus 1 plus I n minus 2 plus I n minus 3 up till I2 plus I1 plus I0, which is equation 2, where I n minus 1 is equal to V n minus 1 by R, I n minus 2 is equal to V n minus 2 by 2R, I n minus 3 is equal to V n minus 3 by 2 square R, and so on up till I0 is equal to V0 by 2 to the power n minus 1 R. Here, Vn is equal to V1 if Bn is equal to 1 and Vn is equal to V0 if Bn is equal to 0. For straight binary input where V0 is equal to 0 and V1 is equal to minus VR and the output voltage V0 with reference to equation 1 is given by, here, since the output swings in one direction, it is thus concluded that the output is unipolar in nature. With V1 and V0 applied to the resistors for 1 and 0 respectively, the output is given by, the offset can be produced in the output voltage V0 by using the previous circuit is given by limitation. The weighted resistor DAC has a major limitation of having a wide range of resistor values R to 2 to the power n minus 1 R, with a required precision and a track over a wide range of temperature. It is thus very difficult to fabricate such a wide range of resistance values in monolithic IC. In today's lecture, we have learned Introduction to DAC, Types of DAC, Weighted resistor DAC. With this, we are at the end of this lecture. We will meet again in the next lecture. Till then, learn and practice. Thank you and goodbye.